Day one of statistics. Okay, today we were talking about visual representations and distribution types. Ooh, fun. Okay, so again, 5-day unit. We're starting off. Today we're going to be just kind of introducing what probability and statistics are. I will say, Algebra 2, we do have probability and statistics standards that we, by law, are supposed to cover. But we're basically just going to kind of touch the surface of what probability and statistics are. Okay, we're not going to get super far in depth with this, but I will say that we offer a really great course called Probability and Statistics that you could take next year if you really like this stuff. And we also offer an AP Probability and Statistics. So if this is something that really interests you, which I kind of find it interesting, and you want to switch into that class for next year if it's not on your schedule already, that would be something that we could talk about after today or after this unit. Okay? Cool. So what is probability? It is just the likelihood that something will happen. And we represent this with the notation P of X, just the probability that event X is going to happen. Okay? You'll notice that probability, it is always between 0 and 1. And if I converted that to percentages, the chance of something happening is always between 0 and 100%, right? There's not a 105% chance that it's going to rain today, okay? That's impossible. But there could be a 0% chance or anything in between up to 100, okay? So that is what that means by probability. We move on to statistics. It says the practice or science of collecting and analyzing numerical data in large quantities. That's what we're going to be doing today. Especially for the purpose of inferring proportions in a whole from those in a representative sample, okay? So basically statistics, we are analyzing data. That's the big thing there, okay? We then move on to population and sample. So the whole group under consideration is the population, just like the population of the world, that's everybody, right? And then the sample is just a small part or a quantity intended to show what the whole is like. So for instance, it would be virtually impossible for me to know how many people in the world have blue eyes, right? Okay, but what I could do is I could take a sample. So I could just try to, for instance, count how many people in this school have blue eyes. Would that be a good reflection of the world? Maybe not. Okay, maybe it would be a better reflection of the state of Missouri or something like that as a population, okay? But that's basically what the difference is. Population is the whole, sample is what you're taking data from. Make sense? Okay, cool. All right, then we've got some different types that we're going to learn about today. The first one's a histogram. This is a type of bar graph, okay? A lot of the bar graphs you've seen so far in your life, you probably made them in elementary school, okay? The teacher said, raise your hand if your favorite soda is Dr. Pepper. Raise your hand if your favorite soda is Mountain Dew, right? And then you counted all the kids in the class. You made bars to represent what your favorite was. Do you with me? Okay. Histogram's going to be very similar, but this time it's going to be quantitative data, which means numbers, okay? Qualitative data is the opposite of that, and that would be letters. Yeah, good. You got it. Just like favorite soda, that's a word, right? Okay. So histogram is going to be numbers. The big difference between what a histogram looks like and what a bar graph looks like, the histogram, the bars are smushed together. Have you seen those before? The bars are all touching. Okay, so that's important to know. Do not put spaces. So make sure on this, no spaces between bars when you draw these. Okay, cool. And then you'll notice that the vertical scale shows frequency. We talk about relative frequency. We'll get into that later. Then we have dot plots. They're exactly what they sound like, okay? It is just a range of data. We represent it with dots, okay? Then we have a stem and leaf plot. We'll talk about that as well, splitting a number into a stem and a leaf and plotting it that way. And then lastly, a pie chart. I know for a fact that you've seen those before, so that is nothing new. Okay, on that quiz today, the two main things that we've got to know how to do are dot plot and stem and leaf, okay? The histogram and the pie chart, also important, but the only two things that are going to be on your quiz are the dot plot and the stem and leaf, okay? So we're going to start off with the dot plot, okay? There's a lot of points here, and we're just going to try to get through as many of them as we can. but here's how this works. So we look through the data. This is the weights of 39 players on the Kansas City Chiefs, okay? So the first point is 315. What I want to do is I want to go between the 300 and the 325, and I want to place a point on where I think 315 would be. And then I cross it off. Then I go to the next number, 205, and then I just keep going, okay? How fun. What? Yeah, just try to get through as many of them as you can. Just start going through them. One thing that is super important to remember on this, and this is the biggest part about these dot plots, so I need you to listen, okay? If you have multiples of the same number, those dots have to stack on top of each other. So if you notice right here, I'm going to pick a different color. I have a 240, a 240, a 240, a 240, and I think that's it. So there's 4 of them. Would you agree? Yeah. You don't see any more? Okay. So I'm going to go to where 240 would be, and I'm going to do 1, 2, 3, 4 dots on top of each other, and then cross those off.
Does this have the actual weight of the player?
What'd you say?
Does it have the actual weight of the player?
Mrs. Schlitt came up with this data, so that would be a good question for her. I would assume that it's accurate, but she could have made it up. I don't know. I wonder what Patrick Mahomes weighs.
My guess is
like 230.
You think 230?
I'm saying 238.
Okay. It's probably on Google. All right, so keep going through these. Let me walk around, see what we got. Okay, everybody's got the hang of this, so we're gonna keep moving on, okay? Just because this is tedious and we know what we're doing. But thank you, Tate. Yes, Patrick Mahomes weighs 230 pounds. Okay? Cool. Do you think he weighs that on the off season too? Or do you think? No.
I think you gained more of that.
Okay. All right. Then we have what is called a stem and leaf plot. All right. Fun stuff. Okay. Same numbers here. We got the same data, but here's our stem and leaf plot. Okay. So basically, the leaf is going to be the very last number. Okay. The leaf is the last number. Last digit, we'll call it. The leaf is going to be the last digit, okay? The stem is what comes before that, okay? So what I mean by that, okay? For instance, 315, my stem is 31. I'm going to put a line here. My leaf would be 5, okay? I'm also going to put a little star right here, or else I could even write the word key. You must have a key when you do a stem and leaf plot. Just showing what you mean, okay? So if you are making this and 31 is your stem and 5 is your leaf, that would be your key. You can pick any of the numbers, it doesn't matter. But you just got to pick one and make a key, okay? That is something that I will be grading you on, so make sure you have that on your quiz. One thing too I want to talk about, let's say instead of these whole numbers we were doing decimals, like so for instance the first number was 35.5, 24.0 and so on, okay? Technically that decimal is still going to be the leaf, okay? The stem would still be 31 in this case and 24 in that other one, okay? So on your key you would want to write, okay, which actually I did this wrong, so hold up. Make sure that you know that this, equals 315. Okay, but like if I were doing decimals, for instance, I would do my key like this, 31 as the stem, leaf as the 5 would equal 31.5. You with me? Okay, but these aren't decimals, so don't worry about that. Okay, cool. So I want you to keep going through this. Here's what you're doing. So the first one, 315, I'm going to go ahead and circle all of the stems that have a 31. Because that one has a stem of 31. Okay, it looks like it's just those two. So we notice that the leaves are 5 and 1. Here's the big thing on this that you have to remember. They must go in numerical order. Okay? So you have to put the numbers in order. So for instance, the stem of 31, I've got 1 and 5 as my leaves, so they've got to go in order. It also may be helpful just to start from the beginning. So it says our first stem is 18. So I go through here, I circle all of the things that have a stem of 18. Okay, I don't think I missed any. So I have a 2, a 0, a 6, a 6, and a 4. So I'm going to put 0, 2, 4, 6, 6, and then cross those off. Okay, so keep going on that. And again, make sure that they are in numerical order. And you have the right stem there. So, okay, so go ahead and check these with my answers, okay? If you're not all the way done, that's okay. Just go ahead and copy down these answers, okay? Because I know that you know how to do this. One thing I do want to real quick talk about as you're copying these down, okay? On the quiz and just moving forward in life, if you ever have to create one of these, okay? They're not going to give you the stems on the quiz. So you've got to come up with the stems. How do you think you would do that? How would you know to start at 18 here? Just the lowest number, yeah. So look through all the data, look through the stems, and find the very lowest one. That's going to be where you need to start. And then you're going to find the highest one, right? And that needs to be where you end, okay? Does that make sense? Same thing is going to go for the dot plot. So if you real quick just flip back to your dot plot, okay? I gave you the intervals there, didn't I? Okay, I think we went up by, what did we go up by?
15.
By 25s, okay? So that's why, so I looked at that data, okay, and I noticed that it spread from 180 to 363. So I decided to go in intervals of 25, okay? Could you have done intervals of 50? Absolutely, okay? Could you have done a different interval? Of course, okay? But it's totally up to you. Just make sure it's consistent all the way through. And make sure you look, my lowest data point and my highest data point need to be included on that, okay? So just make sure you do that. What? Whose name is Donovan? Oh, okay. New Steve. Blue's Clues? Okay. I actually am like recording this hour, so whoever watches this video is going to be really confused.
Nice.
Nice. Okay. All right. Creating a histogram. Fun stuff. Okay. Still going off the same data that we just did, but we're going to be creating a histogram this time. So here's the deal. We've got our weight categories in the left, okay? And then we have what's called frequency. Frequency just means the number of times something happens. So number of times something happens or something occurs, whatever way. So what I need you to do, you can either go back to your dot plot, you could just go to the list of data, or you could go, the easiest thing would be to go back to that stem and leaf, and I need you to count how many people would be in the weight category of 150 to 199 pounds. So how would you do that? Yeah, count the people with a stem of 18 and 19. Go back and do that. How many are there? 6, okay? So I'm going to put a 6 right here. You could also put 6 tally marks, okay? 200 to 249. Somebody count and see how many. 20. That's a lot, okay? 250 to 299. 9. 300 to 349. 3, and then the last category, we've got 1 left. Perfect. Okay, so this is our frequency, all right? Everybody with me so far? Okay, here we go. Histogram. Wow, that was a really straight line. I didn't even use a straight line tool. Okay. X-axis. So just like this table, the X is the weight in pounds and the Y is the frequency. So we're going to label it weight in lbs. Okay, and then frequency is going to be the Y-axis. Okay, so again, a histogram is bar graph. Bars are together, right? And it's numerical data. So if I look at the numbers represented in my x-axis, okay, they're in categories, right? But we see we're starting at 150 and we're going to how far? 399. So we need to make sure we have that represented on that x-axis, okay? So I'm going to go up in intervals of 50 because that's what the weight categories are. So for the very first mark I'm going to do, I might just do a little zigzag and just start at 150. So I don't have to make this super big. Then I'm going to do 200, 250, 300, 350, 400. Frequency. What numbers? What's my lowest frequency? 1, and I need to go how high? 20. So I'm going to go up by 5s, okay? If you want to go up by 1s, 2s, 10s, it doesn't really matter, okay? Just try to make this, bless you, as good as you can. I'm going to do 5, 10, 15, 20. All right, now here we go. Here's where the fun stuff happens. So the very first data point, 150 to 199 has a frequency of 6. So from 150 to right before the 200, and I got to go up 6. This is what my bar is going to look like. Okay, it's not beautiful, but that's okay. If you want to use a ruler on these, that's fine. If you're winging it, that's fine too. Just make sure I can read it and I know what you mean. Okay, so then the 200 to 250. I'm going to go right off the top of that bar up to 20, because again, these are touching. And that is my second bar. As I go through these, I do want to label them. So the first one, I'm going to do 150 to 199. Second one, 200 to 249. And so on. So I want you to go ahead and finish the rest. Okay, not the most beautiful graph that you've ever seen in your life, but this is what it should look like. So if we see this on the EOC, can we read a histogram?
Yeah.
Do we think? Yeah, okay. Let's just kind of analyze this data. You can look at any of the 3 charts that we've made so far, okay? So basically what we've just done is we've taken a sample of data, right? We took one NFL team, okay? So if I asked you a question, if I showed you either that dot plot, okay, if I showed you the stem and leaf, or if I showed you this histogram, and I said, now make a prediction, what weight category do you think most NFL players would be in?
200 to 249.
There you go.
Probably 200 to 249.
You what?
Probably 200 to 249.
Good. Okay. Thank you for repeating that. All right. Any other questions? Do we feel like we could read that? We feel good. You think we should take the quiz? We're not done yet, though. We're almost done. Okay, create a pie chart. We are going to do this quickly, okay? It's not going to be 100% accurate. If we were using a protractor, if we had time today to do that, we would. But we could make a protractor, right? And we could make this 100% accurate with perfect circles and perfect lines, okay? But for time's sake, we're not going to do that, okay? But instead, I'm going to show you what we are going to do. So the first things first is the percentage, okay? We also call this relative frequency. Relative frequency. So frequency was just the number of times that something happened, right? You with me? Relative frequency is the percentage that something happens. So it's the same thing, it's just represented numerically different, okay? So, for instance, if I wanted to find the percentage in that first weight category, so I know my frequency was 6, there were 6 players in that weight category, how would I find the percentage of players in that weight category? Divided by the total, right? How do I find the total? Add everything up. So how many people are there?
39.
There's 39, okay? So for the percentage, I need to do 6 divided by 39. And what do you get?
60.
Uh-huh.
0.15.
0.15, which is 15%. You got it. Okay? We do that for all of them. So the next one, how many people were in that weighted category? 20 divided by 39. What'd you say? 51%. I like it. 9 divided by 39. 0.23. 23%. 3 divided by 39. 7.6%. Okay, and then we're gonna do a whole percent though, so we're gonna round that to 8. And then 3%. Cool. All right. So we are gonna go ahead and make this pie chart just based off of those percentages because that's pretty easy for me to visualize. I'm just gonna kind of guesstimate here and do that. But if we were making a 100% accurate pie chart, I do want to talk about one thing, okay? If we were doing this accurately, we would take this decimal, that 0.15, and we would multiply it by 360. And that would give us the degrees. So do that real quick. 0.15 times 360. 54 degrees, okay? How many degrees are in a circle? 360. So by the time I do all these, they should add up to 360. They may add up to 359 or 361 just based off rounding, which that's okay, as long as you're not off by more than 1, okay? But what these would actually calculate out to be would be 54 degrees, 185 degrees, 83 degrees, 28 degrees, and 9 degrees. So again, if we were using a protractor, we would do it that way, okay? Nope, not on the quiz today. Just the dot plot and the stem and leaf, not the histogram. Okay. All right, so we're going to go ahead. I'm drawing a circle. Wow, beautiful. I'm going to start with the biggest percentage, which is this 51. That's going to be about half, right?
Yeah.
But like a little bit more. Okay, so that's going to be the weights of 200 to 249. Okay, the next biggest is that 23%, which is like about a fourth, right? But a little bit less than a fourth. No, a little more than that. Wow, this is really ugly. That's okay. Thank you. Very supportive today. Okay, 15% is next. We're going to do that. Yeah, you like it? Cool. And again, I'm labeling these as I go, and then I've got an 8%. That looks way too big to be 8, but you get the picture, right?
Yeah.
Most of the time, like EOC and all that, it's going to be not you drawing this. Just going to be analyzing it most of the time, I would think. I should probably double check on that. I will. Probably should. Okay, but we get the picture. We would also want to label this as weights of Kansas City Chiefs players, right? KCC players, not KFC. That'd be pretty cool though. Yeah. We learned about KFC and integrated today. Keep flip change. Keep flip change. Okay. Doesn't apply to this though. Okay, so do we feel like we could analyze this pie chart pretty well?
Yeah.
And we could draw one if we had to?
Yeah.
Do we all know how to draw with degrees on a protractor?
Yeah.
Maybe?
Yeah.
Okay, maybe we'll do that at the end of the year. That'd be kind of fun. It's been a minute. Okay. All right, last but not least, and this is also on your quiz, so I really need you to buckle down and pay attention. This is super important. Super duper important. Everybody with me. Face forward. Eyes open. Okay, here we go. First off, symmetric distribution. Symmetric means what? I could fold it over and it would match. It would match almost perfectly. It's never going to be perfect on these though. It might be, but it probably won't be, okay? But if I look at this graph, this one actually is perfect. But if I folded that in half, do we all agree that it would match? Yes. Okay, cool. So that is symmetric distribution, okay? Then we have symmetric distribution that is bell-shaped. Do we all see that this is kind of in the shape of a bell?
More of a slice of pizza, but.
More of a pizza? Okay. But we're going to call it bell-shaped, not pizza-shaped, okay? But I agree with you. All right, so also symmetric, right? But it's bell-shaped. Do we all see how this one is symmetric and not shaped like a bell?
Yes.
Yes, cool, okay? So again, bell-shaped means it's got a peak in the center and it trails off on the sides. Symmetric means it doesn't trail off on those sides, okay? Then we have skewed left and skewed right. So I told you that the last class, everybody got an 11 or a 12 out of 12 on their quiz. This is the reason why some people got 11, because they didn't pay attention to this right here, okay? Skewed left versus skewed right. You are looking at the tail. You are looking at the tail. Everyone hear me on that? You are looking at the tail. So if you look, this is skewed left because the tail is going to the left. Okay. Why is the other one skewed right? Because the tail goes to the right. Okay.
So left is right.
What'd you say?
Right is left.
So why do they have to put that?
Why do they have to put that?
Yeah.
Why not just make it left is left?
I don't know. I didn't do it. I didn't write the laws of math. It'd be a lot cooler if I did, right?
Yeah, I don't.
What'd you say?
Because I think it's.
Because they weren't
left
listening. They
on the
were
left side.
not listening to me when I said that.
On the left.
And I said it just like that too. I knew they were going to miss it, and they did. I'm kind of like a fortune teller.
Are
Okay.
we your best class?
What?
Are we your best class?
I'm recording right now.
That's funny, actually.
Every class is
Your
my
pause
best
real quick
class.
and tell us the answer.
Okay, bimodal distribution. Guys, listen up. Bimodal distribution. We are almost done. There is another distinctive peak that is not next to the highest peak. Okay? So basically the bimodal distribution is the one that looks weird. Okay? It's not symmetric. It doesn't have a tail on it. Okay? It just looks really weird like this. So it's got a high peak. It's got a peak that's also kind of high but not as high as the other one. Again, no tails on the side. Okay? We don't see a tail here. And it's not symmetrical. So that is bimodal. Okay, and then we got uniform, just like at some schools, they have school uniforms, right?
Yeah, that's
Everybody looks the
the
same.
rule.
Everybody looks the same. So this
No, they
is
won't.
all intervals have approximately the same height. They're not going to be exactly the same, but approximately, okay?
Are we gonna have a word bank?
It's multiple choice, so use process of elimination on this, guys. If it's not symmetrical, rule that out. If it's not bell-shaped, rule that out. If it's not skewed left or skewed right, rule it out, okay? That's going to be your best bet on this quiz. All right, let's real quick. We'll go through an example of each. We'll take this quiz, and let's be done for the day. Okay, number 2 and 3. Actually, I'm going to give you like 3-4 minutes. I want you to do all of these, okay? And then we'll go over them. Not 3 to 4 minutes. You only need like 2. Number two. What do we think?
Symmetric.
Skewed left. Yes, I would agree. It's got a tail, so skewed left. Cool. Number 3. What do we think? Symmetric. Would you call it bell-shaped? Nope. All right. Number 4. Skewed right. Good. Does have a tail going to the right. Number 5. Bell-shaped and symmetric. Symmetric, bell-shaped. Good. All right. Number 6. What'd you say? Bimodal, right? It's got two peaks. One of them's a little higher, and it's not symmetrical. And then lastly, uniform. Bet. Okay. How we feeling? Questions? Any questions on this?
We should probably take the quiz.
Okay, let's do it.